So, hello dear friends, the same problem now we are going to analyze through the section method. The same problem means that the cantilever beam loaded with UDL with the intensity of 1 kilonewton per meter for the length of 4 meter and the point load 4 kilonewton at the free end. So, in previous videos, what we have done, the approach. So, once we started our calculation from the free end and once from the fixed end. That was just to know about which one is simpler method. So now uh, we will go with the section method. So what we are going to do now, so as we know, this is the load diagram. Okay, and what we got, the support reactions, that is at M S A. The support reaction means the moment reaction, the moment resisting moment, it is the moment at the support A. What we get here, 32 kilonewton meter, and VA, after satisfying the equilibrium conditions, we will get VA 8 kilonewton. And then now suppose in between the load AB we are taking considering the section X. Okay, now we're going to calculate now shear force calculation. Okay, so what will be F A, that will be what, that will be VA, means 8 kilonewton. Okay, what about in between F A B? So FAB means now we are taking the distance we are measuring from the XX. This is the X. Okay, so what about now? This will be VA minus WX. So now if X is equal to 0 means we are talking about FA, so we are getting VA, this one, and X is equal to, suppose we put 4. So this is the boundary condition. तो आप देख सकते हैं what is the length of the means UDL load, where the UDL load is acting, that is the 4 meter. That's why either we can take X is equal to 0 or X is equal to the full length is equal to 4. So means we're talking about now FB, and it becomes now 8 minus W is equal to 1, so 1.4 means 4 kilonewton. Okay, and as there is a no load in between the section BC, जो भी लोड है वो C पे है लेकिन इस बीच में नहीं है. That's why the whatever the FC means shear force at C, that will be equal to shear force at B. Okay, so this we have done for the shear force calculation. Okay, and based on this easily we can draw the SFD. This is A, C, B, and it is of 4 meter, it is 2 meter, and this is the magnitude of VA is equal to 8 kilonewton up to here. No, there is a not like that, kilonewton, and here it is 4 kilonewton. So the linear relation is there, that's why the varying profile we will get here, and from B to C it is constant. So this already we know in the previous video. Already I have discussed, I have detailed more, so I'm not going to detail much more about this. Next is the bending moment calculation. Bending moment calculation. Okay, so what about at MA? So MA will be what? Here minus MSA, because in the bending moment sign convention, this we take negative negative. That's why here the resisting moment MSA is acting anticlockwise. That's why here means minus. Okay, and what about in section MA in between AB is equal to minus MSA, and there is a support reaction, and it is acting in upward direction. So upward means it is making like this. So we take it positive in the case of bending moment. So that's why here plus VA then multiplied by X, and what about the UDL? UDL is now acting like this. That's why minus W X. So this is the load, and multiplied by X by 2, as it is acting at the mid of AB. That's why. Okay, so now applying the boundary conditions, if X is equal to 0 means we are talking about MA. So what we are getting? We are getting minus MSA, means this one. So it is verified, and X is equal to, suppose 4 we take, then we're talking about a bending moment, means the resisting moment at B, and it is equal to minus MSA plus 8 multiplied by 4, then W is equal to 1, that's why, and multiplied by 4 multiplied by 4 by 2. So, and this is equal to what? 32. It is 32 minus then 8 is equal to what? Is equal to, we are getting minus 8 kilonewton meter. Okay, and what about the next? So now next, suppose we take a section in between BC. This we are giving, suppose YY. Okay, then from here better to I'm pasting it here. Okay, okay, for this now what will be? This will be X from here. Now it is measured from the YY. Okay, and this is the VA here, this is MSA here, And what about the distance? This load, the UDL is acting at the mid of 4 meters. So means from here, we have to measure, we want this distance. And it is what? It is x minus 2. Okay, so now the bending moment in between the BC is equal to minus M SA, then plus VA multiplied by X, then minus this UDL, that is W, and we have to multiply with the length, that's by 4, and then we have to multiply the distance. So distance x minus 2, and now let us satisfy the boundary condition. If x is equal to 4, then we are talking about MB. So what we are getting here, 32, and it is 8 multiplied by 4, 1, 4, and it is x is equal to 4, so 2 minus 32, and it is 32, it is minus 8. Okay, so we are getting the same, so it is verified here, means our equation, this one equation is correct. Okay, and now if x is equal to 6, the length of the beam, total length of the beam, then we are talking, means we are talking about the MC. Then what we get by satisfying this, so, and 8 multiplied by 6 here, 1, then 4, then it is 6 minus 2. Okay, then what we get, minus 32, and 48 minus, then 4 into 4. So 40 minus 48 plus 48 is equal to 0. So it is obvious at the free end there will be no bending moment, so it is verified. So in this way you can see through the section method we have also got the answers like previously, and now the bending moment diagram. So just below the load diagram, bending moment diagram here, A, this B and C, and a bending moment with negative direction, so that's why it is 32 in the negative direction. And what about at B? So at B we are getting minus 8, so it is like this, 8. And what about B and C? So at C it becomes a 0, and the linear equation is there, that's why linear profile we will get. And what about in between AB, we are getting the parabolic, that's why it becomes like this, it's negative, it is negative. So in this way we have drawn the SFD BMD by calculating their values. So with this, thank you.